Right now, at this very second, the most powerful companies on Earth are in a war. Google, Meta, Microsoft, Amazon, Apple. They are spending a combined $1 trillion building something they cannot afford not to build: artificial intelligence infrastructure. And here's the part that keeps CEOs awake at night. No matter who wins that arms race, one company collects the toll: Nvidia. They control over 80% of the global AI accelerator market. They are worth more than the entire GDP of Germany. And last quarter alone, they generated $62.3 billion in a single business segment in 90 days. But to understand how a 34-year-old immigrant built an inescapable $4.5 trillion monopoly, you have to travel back to 1997, when Jensen Huang had exactly 30 days of payroll left. Half his staff had just been fired, and the company he had built was about to be erased from history. This is the full story. The year is 1993, a Denny's diner, Silicon Valley, California. 3 engineers slide into a booth. Their names: Jensen Huang, Chris Malachowsky, and Curtis Priem. Jensen was 30 years old. He was working at LSI Logic. His co-founders came from Sun Microsystems. They ordered coffee, opened napkins, and started sketching a company. Their observation was simple. Computers were getting faster, but they were absolutely terrible at one thing: rendering complex 3D graphics. The CPU, the central processing unit, the brain of every computer, had to do everything: run your spreadsheet, check your email, and draw every single pixel on your screen, one at a time, sequentially. They decided to build a dedicated chip, a chip that did one thing and did it better than anything else alive: graphics. They called it Nvidia. Jensen later said he chose the name because NV sounded like next version. He would write it in his calendar every day as a reminder that the company always had to be a next version of itself. The name Nvidia also references the Latin invidia, meaning envy. Some historians believe this was intentional. Either way, every competitor has spent 30 years wishing they had built what Jensen built. Here is where the first disaster happens, and it is the kind of detail that nobody talks about. In 3D graphics, you build shapes out of polygons, simple geometry. And there are 2 ways to do it: triangles or quadrilaterals. Nvidia made a fateful bet. They built their first 2 chips, the NV1 and the NV2, around quadrilaterals. Then Microsoft dropped the bomb. They released Direct 3D, an industry-wide graphics standard, and it was built exclusively around triangles. Overnight, Nvidia's entire architecture was obsolete. Sega pulled their funding. A key hardware partner walked away, and Jensen Huang sat in his office, staring at a balance sheet that told him he had enough money to design exactly 1 more chip. Not 2, not 3, 1. If that chip failed, Nvidia was dead. Company size: 40 people. Remaining cash: enough for 30 days of payroll. Product strategy: wrong. 1 chance left. Jensen made the call. They would abandon everything they had built. They would pivot to triangles. And they would not just build a graphics chip. They would build the most ambitious graphics chip anyone had ever attempted. They called it the NV3, but the world would know it by a different name: the RIVA 128. It sold 1 million units in 4 months. Nvidia was alive. But more importantly, Jensen Huang had learned the most valuable lesson of his career. The companies that survive are not the companies that are always right. They are the companies that are able to recognize when they are wrong and move faster than anyone expects. Let me ask you a question. Imagine you need to paint a football stadium. You have 2 options. Option A: hire the world's greatest painter, the absolute best. He is fast, intelligent, and precise. But he can only work in 1 spot at a time. Option B: hire 10,000 average painters and send them to every corner of the stadium simultaneously. Which is faster? That is the difference between a CPU and a GPU. And in 1999, Jensen Huang bet the entire company on the idea that the future belonged to the 10,000 painters. In 1999, Nvidia released the GeForce 256. But they did not just release a chip. They coined a brand new term, the graphics processing unit, the GPU. And here's the hidden detail that Wall Street still underestimates. Rendering graphics is just solving millions of simple math problems simultaneously. You need to calculate the color, position, shadow, and lighting of every single pixel on your screen, all at once. A CPU does things one at a time, brilliant and sequential. A GPU does millions of things simultaneously, simple but massively parallel. Intel looked at this and laughed. Their strategy was to make the CPU so fast it could handle everything, including graphics. They were building a smarter, faster executive. Nvidia was building an army. Intel's fatal mistake was not laziness. It was intellectual arrogance. The CPU architecture was so elegant and so profitable that Intel's engineers genuinely believed faster sequential processing would win. They were optimizing a horse when the world was about to need a rocket ship. This is the classic innovator's dilemma, and it cost Intel a decade. What Jensen realized, and what Intel refused to see, was that the exact architecture he had built for video games was going to be the only viable architecture for artificial intelligence. The math was identical. Training a neural network means performing millions of identical calculations on massive datasets simultaneously. You needed the 10,000 painters, and Nvidia had been building them for years. By 2006, Nvidia was extremely profitable. Gaming chips, workstation graphics, a clean, simple business. Then Jensen Huang did something that Wall Street absolutely hated. He launched CUDA. CUDA stands for Compute Unified Device Architecture. Here's what it actually is: a software layer that lets any programmer, not just graphics engineers, talk directly to the GPU using standard coding languages like C++. For the first time in history, a scientist studying climate change could use a gaming GPU to run their simulations. A molecular biologist could use it to model protein folding. A physicist could simulate the Big Bang on hardware that cost a few $1,000s. Jensen saw what nobody else on Earth saw. The GPU was not a graphics tool. It was a general-purpose supercomputer that happened to be disguised as a gaming chip. And CUDA was the key that unlocked it. Here is what that cost. Building CUDA required Nvidia to redesign every single chip they made from that point forward to be CUDA compatible. Every chip, past and future. The R&D bills were in the billions. Profit margins collapsed. The stock went nowhere for years. Wall Street analysts launched a public offensive. One famous analyst note from 2008 read, essentially, Nvidia is a graphics company throwing money into a software pit that no customer has asked for. This is mismanagement. Jensen kept building. Fast forward to 2012. A global AI competition called ImageNet. Thousands of researchers submitting computer vision models. A PhD student at the University of Toronto, Alexnet, working under Geoffrey Hinton and alongside Ilya Sutskever, submitted a neural network called AlexNet. Here is what almost nobody includes in this story. Training AlexNet on a CPU would have taken months. It would have been impossible to compete. But Krzyzewski had spent 6 years watching Nvidia build CUDA. He bought 2 off-the-shelf Nvidia GTX 580 gaming GPUs for a few $100s each, rewrote his code using CUDA, and trained AlexNet in days. AlexNet didn't just win ImageNet. It won by a margin that stunned the entire field, 10.8 percentage points ahead of the second-place entry. The gap was so massive that every AI researcher on Earth immediately understood what had happened. The Big Bang of modern AI had detonated, and it ran exclusively on CUDA. Because CUDA only worked on Nvidia chips, and because CUDA had been embedded in the workflow of every AI researcher, every PhD program, every research lab for 6 years, the moat was sealed overnight. You could not do AI without CUDA. You could not run CUDA without Nvidia. Jensen had spent 6 years, billions of dollars, and his stock price building a trap. And in 2012, the entire AI research community walked straight into it. August 2016. A little-known nonprofit startup had just opened its doors 6 months earlier in San Francisco. It had big ambitions and modest funding. Jensen Huang drove to their office, and he walked in carrying a small black box. Inside that box was the world's first AI supercomputer, designed to fit in a single server, the DGX-1. It delivered 170 teraflops of compute, the equivalent of 250 standard CPU servers compressed into the size of a gaming console. Jensen handed it to the co-chairs of the startup, Sam Altman and Elon Musk, and reportedly said, "This is for you. Go build something incredible." That startup was OpenAI. That box was the first tool used to build the foundational research that eventually became GPT-2, then GPT-3, then GPT-4, then ChatGPT. This was the moment the world changed forever. When ChatGPT launched in November 2022 and became the fastest-growing consumer product in human history, reaching 100 million users in 2 months, every hyperscaler on Earth had the same realization. AI was not a research project. It was the next internet, and the only way to build it was Nvidia. Microsoft, Google, Meta, and Amazon collectively spent over $200 billion on Nvidia hardware in 2023-2024. Nvidia's H100 chip, the Hopper architecture, sold for $30,000 to $40,000 per unit. Lead times stretched to 6 to 8 months. Nvidia's revenue went from $27 billion in FY 2023 to $215.9 billion in FY 2026. This is not growth. This is a vertical wall. By 2024, Nvidia realized that individual GPU performance was no longer the bottleneck. The bottleneck was communication. How fast could tens of thousands of chips talk to each other? Enter the Blackwell architecture, the B200 GPU, and the revolutionary NVLink 5 interconnect. NVLink is Nvidia's proprietary chip-to-chip communication system. Think of it as a private highway between GPUs. While standard networks communicate in gigabytes, NVLink communicates at terabytes per second. A Blackwell NVL72 rack, 72 B200 GPUs linked together, does not function as 72 separate chips. It functions as one unified brain with 720 terabytes of total memory. This was the moment when Nvidia stopped being a chip company and became an AI infrastructure platform. You are not buying a chip. You were buying a cognitive architecture. Early Blackwell production suffered overheating issues. The racks ran so hot that some deployments were rolled back. The issue was fixed, but it delayed the ramp by 6 weeks. December 2025. Nvidia announces a $20 billion acquisition of a startup called Groq. They did not build GPUs. They built something called an LPU, a language processing unit. Groq solved the inference bottleneck. Their chips generated tokens at 5 to 10 times the speed of a standard GPU, while using a fraction of the energy. Think of Nvidia's GPU as a jet engine. Incredibly powerful, but it needs a turbocharger to feed fuel faster. Groq built that turbocharger. Jensen bought the turbocharger company and welded it permanently to his own jet. The result? The Groq 3 LPU, now the 7th chip in the Rubin rack. By acquiring Groq, Nvidia did not just neutralize a competitor. They acquired the solution to their own architectural weakness. Now nobody else gets to fly at full speed. March 2026, the SAP Center in San Jose. Tens of thousands of engineers, researchers, and investors filling an arena. And Jensen Huang walks on stage. He does not start with financials. He starts with a declaration. Data centers are dead, he says. What you are building now are AI factories. A data center stores information. An AI factory produces intelligence in the form of tokens. Every query answered, every task executed, every agent deployed, each one a manufactured product. And then he unveils the Vera Rubin platform, and it is not a chip. It is a complete computing civilization. 7 chips, 5 rack types, 1 AI supercomputer in a box. The NVL72 rack, 72 Rubin GPUs plus 36 Vera CPUs plus 36 Groq 3 LPUs. Fully liquid cooled. No air cooling option. This is mandatory, not optional. Performance versus Blackwell. 1/4 the GPUs needed to train large mixture of experts models. 10 times higher inference throughput per watt. 1/10 the cost per token. Every hyperscaler that retrofitted their data center for Blackwell now faces additional capital expenditure to support mandatory liquid cooling for Rubin. This is not a hardware upgrade, it is a facility upgrade. Cooling infrastructure, floor reinforcement, new plumbing. The cost is estimated in the hundreds of millions per hyperscaler, and it is deeply embedded into Nvidia's MGX reference design architecture. Once you build for MGX, you are on Nvidia's roadmap forever. Then Jensen does something stunning. He raises the demand bar. He tells the audience, and the watching investment community, that cumulative order visibility for 2027 for Blackwell and Rubin combined is now greater than $1 trillion, without a single dollar from China. That means rest of world demand has doubled in 12 months. That means the $1 trillion compute cycle is not coming. It is here. Revenue, $215.9 billion, up 65% year over year, growing faster than any $200 billion company in history. Data center revenue, $62.3 billion in 90 days. That is 91.5% of revenue. One segment, one platform. Gross margin is 75%. Every $100 leaves $75 before rent or salaries. Net profit margin is 55.6%. Better than Apple, better than Google. Operating cash flow is $102.7 billion, enough to buy Disney or Netflix every year. On a growth-adjusted basis, this company is cheaper than the S&P 500 average. This is not expensive, it is mathematical theft. If Nvidia makes $100 in revenue, 75 of it becomes profit before they pay a single employee or $1 of rent. Apple keeps 25. Google keeps 24. Nvidia keeps 75. That is not a tech company. That is a toll booth. Your viewers trust you because you show both sides. Risk 1. China export controls. 50 billion plus of annual potential revenue is permanently inaccessible. Geopolitical escalation could further restrict non-compute sales. This is real, ongoing, and non-recoverable. Risk 2. Supply chain ceiling. Rubin GPU production is deliberately capped due to TSMC advanced packaging and memory supply constraints. One Samsung yield failure or TSMC capacity crunch changes the entire story overnight. Risk 3. Customer concentration. Microsoft, Google, Amazon, and Meta represent over 50% of data center revenue. If any one hyperscaler shifts meaningfully to custom silicon, the revenue base cracks. Risk 4. CUDA mode erosion. AMD's ROCm is improving. A generation of cloud-trained developers may never touch CUDA. If the software moat softens over 5 to 7 years, Nvidia's pricing power compresses. Risk 5. Inference economics disappointment. If large language model efficiency improves faster than expected, the demand for raw compute could temporarily plateau. Agentic AI, the next demand driver, must materialize on schedule for the $1 trillion forecast to hold. In 1997, Jensen Huang had 30 days. He had a company of 40 people, a dead-end architecture, and one last chance. Most people in that position would have played it safe, built the chip that customers were already asking for, taken the revenue, survived another year. Jensen did the opposite. He made the chip nobody asked for. He built the software nobody needed yet. He spent a decade absorbing Wall Street's attacks to lay a trap for a revolution that would not arrive for another 6 years. And then, when the revolution came, every single participant had no choice but to walk through his door. The most dangerous companies in business are not the ones with the most resources. They are the ones with a CEO who sees 15 years into the future and is willing to suffer the present to build it. Nvidia is not a chip company. It is a platform monopoly that happened to start with chips. The question is not whether Nvidia is worth $4 trillion today. The question is, in a world where AI inference runs every business, every government, and every device on the planet, what is the appropriate price for the company that owns the platform? That is the question Jensen Huang answered in 1997, at a Denny's diner, on a napkin. If you made it to the end, you now know more about Nvidia than 99% of investors on Wall Street. Drop your biggest takeaway in the comments. I read every single one. If you want the short reels, the survival story, the OpenAI box, and the Groq acquisition, they are linked in the description. And if this brought you value, subscribe, because the next case study is going to be even bigger.